Okay, we're going to start into fractions, and we're going to simplify, then we'll add, subtract, then we'll go into multiply and divide. And before we start anything, as we go into simplifying, an important, very, very important word is factor. Right? We can't simplify fractions unless there's a common factor. I'll give you a simple example here. If we had 3/9, most of us know we can simplify because there's a 3 here, and this you can put 3 into 9 3 times, so this simplifies to 1 and this to 3. Okay? Now, that probably is not well defined in most of our minds as them having a common factor, and if it is, even then, you may not have well defined what a factor really is. Okay, because a lot of confusion comes up over this. When things have common factors and when they don't. So let's just go back. I'm going to erase all that and start with what a factor is. Because when we start simplifying, we start cross-canceling, and we start looking for common denominators and everything, we're going to want to know about this word factor, as well as the word multiple. But let's start with factor. Say I go 3 times 5, and that's 15. Because very specifically there's this multiplication that take 3 and 5, you multiply them together, and that's 15. Because it's multiplication, 3 is a factor, 5 is a factor. Okay, let's look at something else. 6 times 5 equals 30. Okay, so just as before, 6 is a factor, 5 is a factor, but look, I could write 6 as if I factored 6. Hear that word factor again. I'm going to factor 6 as 2 times 3. Now that's the same as 6. I'm going to multiply that by 5. That's still 6 times 5. Okay, 5 is a factor, 6 is a factor, 2 is a factor, 3 is a factor. Anytime that you can multiply stuff together, anything that gets multiplied, and multiplication only, multiplication alone without addition or subtraction or division, then that would be what we call factors, and that's the definition of things being factors. So keep that in mind when we start to simplify things. They have to have factors in common, not just terms and not just numbers in common, but factors. And I'll show you a reason why I want you to know this really well, because if we get in a situation like this and you say, well, x is up here and x is right here, so what I'm going to do is cancel this x and this x, and then let's say that you say, well, there's a 1 left here, so there's a 1, it's 1 over 1. Okay, well, I'm going to show you why that doesn't work, because let me just give you a counterexample. Instead of an x, let me just substitute a number, say 2. Okay, so instead of x, I'm going to write 2. And then, you come along again and you say, well, there's a 2 up top and there's a 2 down here, so I'm going to cross them out. Okay, and now that I've crossed them out, again, like I said before, there's a 1 and a 1. But let's do the problem a different way, and instead of canceling, let's just add these together. We get 2 plus 1 over 2. That's going to be 3 over 2. 3 over 2 is not the same as 1 over 1, and I bet everybody out there can see this is absolutely a correct way to go about it. Add things up here, it's 3, and then nothing's going on here, so it's just 2. That's 3 halves, it's not the same as 1 over 1. Okay, and the reason that is, it's because this is addition here. There's no multiplication going on. I'm adding them together. Alright, so the short story, to make a long story short, is if you don't see multiplication between the two things, then you can't do this cancellation like this. On the other hand, if it were, say, 3 times 7 over 3, okay, now we've got a 3 and a 3, and they are common factors because they're multiplied. Okay, that would be 7 over 1, or just 7. Alright, so let's look at another kind of example. Say, let me just kind of draw a little line here. Let's say that you have x plus x squared over x. Alright, so we're looking, and before, when we were over in here and we didn't know better, we might have tried to do x and x. Okay, and then we know, oh, there's addition, we can't just do that. Okay, but there is cancellation that can happen here. There is simplification that can go on. And the thing we always need to ask ourselves is, my eye jumps to x. X is immediately in question. Is there a factor of x in the numerator? Okay, just because there's an x there doesn't mean that there necessarily is one, but there could be one if this also has a factor. So what we want to ask ourselves is, since I want x to cancel out, if x is going to cancel here, it needs to cancel here. If it's going to cancel up here, then x needs to be a factor of the numerator. And remember what we said a factor was way back at the beginning. A factor is, right, because 3 is multiplied by 5 to get 15, then 3 is a factor and 5 is a factor. If you can multiply two numbers together, or many numbers together, they're all factors of the final number. Okay, so if I could multiply x by something and get x plus x squared, then I could have a factor. So let's look at it this way. I want to multiply x by something, okay, and I want the result to be x plus x squared. Well, if we know a little something about distribution, I know that I'd have to, in order to multiply x by this first thing and get x, this would need to be a 1. X times 1 is x. Plus, what would I have to multiply x by when I distribute it here to get x squared? Well, that would need to be an x. Alright, so now I have it in this form where x is multiplied by this a quantity. So there's just this multiplication going on between x and this thing. So x is a factor of the numerator, x is a factor of the denominator, so I can cross them out and write what's left. And this has just been rewritten as this up here. So up top we have 1 plus x left, and down below this has been cancelled out, so there's just a 1 left, so we have 1 plus x. Okay, so that should sum up simplification pretty well. Alright, and factor. Always refresh yourself on that word factor. If it's a little fuzzy, don't let it be anymore. Okay, let's move this up. Okay, now addition. Just a quick example, 1/2 plus 1/3. Is this 2/5? That's a question. Well, hopefully we know by now. No, it isn't. I can't add a half and a third. It's like trying to add an apple and an orange. Okay? I could add an apple to an orange and say, I have two pieces of fruit, because that is what they are. They're both fruits. But that'd be the same as saying 1/2 plus 1/3 is 2 fractions. That's not really a mathematical answer. Okay, so what we have to do is find a common denominator. Okay, now remember that a common denominator is also a common multiple. That's exactly what the common denominator is. It's a common multiple. That means something, a number, that 2 goes into and 3 goes into, both 2 and 3 go into, and have that be the smallest number that could have, because 2 could go into, let's see, what could 2 go into? 36. 3 could also go into 36. But if you spent any time around fractions, you know that if you use too big a denominator, it just gets more complicated. You have to simplify at the end. So that's why we look for the least common denominator. Okay, and we should be able to see that 6 is this common denominator. If I want to get this to be in terms of sixths, I know that I have to multiply 2 by 3 to get 6, which means I also need to multiply the numerator, 1, by 3. Okay, and then if I want to do this with 1/3, I need to multiply them both by 2. Okay, and don't be mystified by this. Don't think it's something you have to memorize. I like you to memorize as little as possible. Uh, we there's generally two things we look for in solving math problem. Can we do it, and why would we do it? Um, can I multiply 1/2 by 3 over 3? Well, sure, because 3 over 3 is just 1, and if I multiply something by 1, it hasn't changed it. So I could multiply this by a million over a million. It wouldn't make a difference. It wouldn't make a difference in the size of this fraction. It would still be worth half of a whole. Okay, so that, yes, I can do it. Why would I do it? Well, because if I do it, let's go ahead and do it. Then this would be 3/6. This would be 2/6. Now I've got something to compare here, okay? If there was some kind of exchange rate for apples to oranges, I could trade in my apples and get a certain number of oranges, and I'd have 3 oranges and another orange, and then I'd have 4 oranges. All right. So the same thing holds here. Now I've got something I can compare, a 1/6 and a 1/6. These are good. I have 3 of them here and 2 of them here, so altogether I have 5 of them, 5 of these 1/6. Alright, so that's why we would do it, is because if we do it, which is allowed, if we do it, then we can compare these two, then we can put them together, right? That's the whole thing, that's the whole goal. So now let's look at, a slightly more complicated answer, or a problem, rather. Let's say 9 over y minus 3 plus x over 2x. Okay, so that now we're looking for a common denominator. Clearly they're not common, they're not the same, so I need to find that common denominator. Can I multiply y by something to make it into 2x? No, not really. So I'm going to have to multiply these both by something. I'm going to wind up having a common denominator of 2 times x times y. And to get this to be 2 times x times y, I need to multiply this by y, and therefore the top by y as well. And here I need to multiply this guy by 2x, the numerator by 2x. Alright, so I'm going to block this off. I'm going to bring my work up here. 9 times 2x, 9 times 2 is 18, so we have 18x. And 2 times x times y, well, that's just 2xy. Minus, we've got 3 plus x times y. Now we've got, if it helps you to draw some parentheses, remember, you're multiplying all of this by all of this, which means distribution. So y times 3 is 3y. Plus x times y is xy over 2xy. Look at it again, we have apples and apples. Two things that are the same, now we can put them together. Okay, so the next thing to remember is when we have subtraction here, all the denominator work is the same as for addition, but with subtraction, I'm subtracting all of this, okay? And really importantly, remember, I'm subtracting this whole thing from this whole thing. And if I'm subtracting this whole thing, the negative applies to everything in here. So here's what happens. 18x minus a 3y minus a positive xy. So minus a positive is just the same as minus xy. And this is all over 2xy. Once we find the common denominator, that's what we're saying. We're basically saying there's this many of these things. Right? Just like over here. We're saying there's 5 of these 6. We're saying there's these many of these things. Okay. So, there's a couple examples. Addition, subtraction. Alright, now let's try a little multiplication. How about 19 over 7 times 5/3? Alright. Now here's the thing that if you only listen to this first part, you'll be good. When you multiply fractions, you multiply straight across. All right. I'll tell you later what you don't do, but if you just remember that you do multiply straight across, you'll be in good shape. All right. So this is 55. Is that right? No, that can't be right. It's 95. 5 times 19 would be 95. And then 7 times 3 is 21. Good. That's pretty much it. But now let's say we wanted to take 2/3 times 1/4. Alright. Now, no problem. Straight across. 2 times 1 is 2. 3 times 4 is 12. But look at what we have here. Now we're simplifying. Right? We're going back to the simplifying. Well, this would be a 1/6. Which is not a big deal. If it's just these little fractions here, you get to the end, you simplify. You can save yourself a lot of time if you get in the habit of cross-canceling. Okay? Because essentially, you know, what's really going on here, if we're multiplying straight across, we could just say this is all one fraction, and each of these things gets multiplied together. And remember, you know, now that these are multiplied, 2 is a factor of what's up here in the numerator, 1 is a factor, 3 is a factor of the denominator, 4 is a factor of the denominator. And if we have factors in common, we can cancel, and 2 is a factor of the numerator, 2 is a factor of 4, and 4 is a factor of the denominator. Right? This is 2 times 2, just rewriting it. Then 2 is also a factor of the denominator. So now all we have left is 1, that is here, and 3 times 2, that's 6. So look for the cross-canceling, and without rewriting it in this funny-looking way. You know, just multiplying these two together. I look across here. I see 2 cancels with 4. This becomes a 2, and we have 1/6. All right. Now, I would like to show you what sometimes does happen that shouldn't happen. Let's say we go back to 2/3 again times 1/4. You think two fractions, and you hear the word multiplication, you think cross multiply. Now let me show you the problem here. Why, even if you decided on cross multiplication and you were just going to go for that, why it just doesn't work? Because we got to come up with some kind of a set of steps. So I'd go 2 times 4 if I cross multiplied, if that was the way to go. 2 times 4, that's 8. Okay, now where do you put that 8? Where does the 8 go once you find that 2 times 4 is 8? Does it go up here because the 2's up here? Does it go down here because 4 is down here? Okay, so let's just decide. That should start to show you that there's something not right about cross multiply. So 2 times 4, let's say that we've just decided that the 8 should go here. I should put this, actually it's not going to work, right? I'm telling you cross multiplication is not the way to go. So 3 times 1 is 3, so this must go up here. Since the 8 went down there, the 3's got to go up there. Okay, so 3/8. So let's say that we decided on this order of operations here for cross multiplying. Okay, and just showing you why it doesn't make sense. 2 times 4, we put the 8 down there. I guess because the second one was on the bottom, we decided to put it on the bottom. What if we put it in the other order? We know that when you multiply two things, it doesn't matter the order you put them in, right? So let's go the other way. Well, we'll go 1 times 3. You know, I'm going to put the truth here. It's not equal. But just to entertain ourselves here. 1 times 3, well, that's 3. Okay, we kind of do this action. We decided. We go from here to here and put it on the bottom. And so we go the other way, and this is 8. Okay, when I switch the order of multiplication, you should get the exact same answer. But I don't. I actually get two different numbers, 3/8 and 8/3. This should start to show you that cross multiplication is, it's coming up in your brain as what you use, but your brain is telling you the wrong thing. Okay? It just kind of mixed stuff up. When you use cross multiplication, let's just separate everything and then I'll separate this off. When to use cross multiplication is, say, when you have x over 3 equals, well, let's say, over 6 equals 2. Am I even doing this right? I don't know. Doesn't really matter. Right? You're solving for x. Somewhere along the line, somebody gave you this catchphrase and this thing to use. They called it cross multiplication, and they meant when the two fractions are equal to each other. But so many of us do this when we're multiplying. We say cross multiply. But cross multiply is actually for when two fractions are equal to each other. So what they told you to do is cross multiply. So cross multiply, and this comes up with the right answer. 5x equals 6 times 2. That's 12. You divide by 5. You get x equals 12 over 5. Right? Perfect. That's what we're looking for. But that is cross multiply is when it's used for when two fractions are equal to each other. That's what we call a proportion, when two fractions are equal to each other. So that's the scenario for cross multiply. Your brain, maybe because you didn't fully internalize it, knows that cross multiplies for fractions. It hears the word multiply, and it thinks, oh, when you multiply fractions, you cross multiply. But that's just not the case. So don't let that trip you up. Okay, last deal is division. It's pretty quick. Let's say you have 1/2 divided by 3/7, something like that. The only thing you need to do is multiply by the reciprocal. The reciprocal is just this guy flipped over. Okay, if you're dividing by this, flip that over. If I flip that over, and then I multiply. So that's 7 over 6, and you're done. That's it. Another way that it might look is if I have 1/2 over 3/7. That's division 2. So I just always in my head, this guy flips right over, comes up next to it, and gets multiplied. So 1/2 multiplied by 7/3, and then we get that 7/6 again. Okay. So to recap, remember the word factor. Remember that to cancel things out in fractions, you need common factors. Which means, this means a lot of stuff. This one word means that you have to know a lot of things. That a factor is when you're multiplying, it's not when you're adding, so you can only cancel out, you can only simplify when there's a common factor, which sometimes you have to look for the common factor. Also, when you're adding, you need a common denominator. Remember common denominator. Right, and look for the least common denominator, the smallest number that both denominators go into. Okay, and then when you multiply, period, abbreviation there, multiply straight across. Alright, don't be going crazy and doing cross multiplying. Don't do that. Okay, and for division, just do multiplication, but use the reciprocal of the one that you're dividing by. Right? I'm dividing by 3/7 here. I'm going to multiply by 7/3. I'm dividing again by 3/7 here. I'm going to multiply by 7/3. So you find the reciprocal of the one you're dividing by. So multiply by reciprocal. Okay. So I hope this was helpful. Good luck. Let me know if you need any help.